Okay, let's interconvert from name to formula. Here we have a formula. Let's give it a name. The general rule is that if it's a salt, we do not use monodi-tri, but if it's a covalent compound, we do. How do you know if it's a salt? In general, and that's almost always, it starts with a metal and it ends with a nonmetal. In turn, you can tell that from the staircase. To the left of the staircase, we've got the metals, and over here we've got the nonmetals. This is clearly a salt. Sodium is over here. Oxide is right here. So we're going to call that not disodium oxide, just plain old sodium oxide. There's another rule that says you better specify the charge if it's in the middle. Generally, that's right around in here. It's not. It's on the edges, so sodium oxide is fine. But iron is in the middle right there. So what's its charge? Let's figure it out. We definitely have an iron. We definitely have an oxide. Notice we tend to finish in IDE. Oxygen becomes oxide, just like sodium plus chlorine makes sodium chloride. Oxides tend to be -2 because they have 6 valence electrons. That's a -2 there. Therefore, the iron must be +2 to offset that. Ionic compounds are uncharged overall, giving us iron 2 oxide. Now, maybe you know this just from sort of muscle memory. This is carbon monoxide. Notice we are using monodi-tri, and that's reasonable because this is not a salt. Both carbon and oxygen are to the right of the staircase. Aluminum oxide sounds like a salt to me. Let's verify. Aluminum, check, left of the staircase, although just barely. Oxide, we know, is to the right of the staircase. Metal to a nonmetal. So we're going to write Al, and oxide, we're going to write O. Looking up their charges, we find aluminum tends to form a +3 cation. I'm just going to make a personal note of that. And oxides tend to be -2. That's right there. Drop and switch, you may have learned that. Al2O3 will be our answer. I do have an erasable pen, isn't that amazing? Those were just personal notes, so I think I'll get rid of them. The 2 +3s offset the 3 -2s. +6 here, -6 there. Looking good. Last one, copper 2 nitrate. Well, copper is in the central region. I guess I'll show that to you right there, not cobalt, copper right there, but that can go +2 or +3 commonly, but we just know that it's polyvalent and it's got a nitrate on it. Now, what is a nitrate? Nitrate is right there, NO3 with a -1 charge. So this is 2 by definition, that's -1. So I'll write my Cu and I'll write a nitrate, right? And I'll write my little +2 charge here, I'll write my little 1 charge there. I need 2 nitrates and 1 copper. I'm not going to bother with the 1 there, but to show 2 entire nitrates, I'm going to write it like that. This is copper to nitrate, and that's a little bit about interconverting from names to formulas.